Hello there. Today we will dive into Japa. So Japa is basically a prompt optimization technique which uses different approach, and there's a whole paper here. But one thing recently happened is Japa came as a DSPy optimizer, so you can use it as a DSPy optimizer. So I tried it, experimented with the Japa, and I integrated Japa with the SuperOptiX. So let's go through the experiment I have done. And let's take one example of the agent and then see how the Gepa performs on that. I have created an open source repository for that evaluation. So you can find that repository on GitHub. It's called Gepa Evaluation or Gepa-Eval. In the terminal, we have a Gepa demo project here. So let's clone this repository. Let's get into that and see. Probably open into the editor. So this repository has a couple of agents, and I created two agents, one for targeting the small system, one targeting the higher end machine. So you can run this optimization based on your configuration. So this light one has a playbook. So this is using llama 3.21 billion model, and it has a Japa configuration. So we have this repo, have some like a getting started script. If you want to do some setup or run this directly, get it set up. So we can do this setup using setup script. So what that will do is basically create a virtual environment and then like do the basic Python setup. We have this script which is running on the light machine. Let's try this first. What it is doing basically, it is using this agent and doing compilation and then optimization and evaluation. Let's run this script. So it's checking your system requirement. You have to be a bit careful because you don't have to be running this optimization on very low end machines because it is making a lot of LLM calls. So let's do it now. It means it created the pipeline successfully. Now it's running it before it does anything. And after that, it started the optimization. So Japa started doing optimization under the hood. So this is gonna go for long because Japa is going to do a lot of LLM calls and then trying to select the best candidate. So as we go, it is finished now. So unfortunately, in this case, it didn't propose new candidate. As you can see here, it performed the 109 iterations, but it didn't mutate or propose a new candidate. You can see there's like it selected the program, it gave the score and all these things because we're using the very lightweight model right now. So this is advanced one. Let's try and see what this advanced playbook look like. So in advanced one, we are using llama 3.18 billion. And in the Japa, you can see we're using 0.38 billion as a reflection. As you can see, we have more examples here. So in terms of, we will run this script called run demo. Start is going to compile it, evaluate and run it. So at this stage, what it did basically, it just ran the agent before doing the optimization. So it gives some results back. Now it's asking to start the Japa optimization. We continue. So it might take 5 minutes. So basically, we're not going to carry on this one because it's going to take some time. It's going to make our machine hot, and then like after that, the Japa will suggest propose some optimized prompt at the end of this cycle. You can try it yourself. But now you can see this like Japa is doing its job now. You can see here, it's the first iteration, propose a new text predictor, and then it is doing its job now. So let's stop this for now and continue on that one and see what else you can do with the Japa. So on SuperOptiX website, we got a full documentation, what is available and what you can do. There are different agents available. So you can try data science agent. How you can try that? You can go to documentation and there's a full list of agents, the configuration that you can do in a playbook, as well as, so you can have a look at the documentation and try all these agents. You can see there's a commands to run those agents. Also, you can take a look at the DSPy optimizers if you want. So you can try other DSPy optimizers and compare them. For example, you can compare Simba and Japa for your use cases and see what you can find, basically. So there's the reference for the API and CLI if you want more information, but it'll take you to the dig more into the Japa integration. So you can find some playbook configuration. You can try with like a different reflection LLM or try different and play around. So you can add as many examples as the scenarios. So the scenarios will act as your training data. So you can give it a go. There's a open source GitHub repository as well. So if you find any issues with that, just feel free to create the issue. You can find more information about the Japa and how you can use the DSPy. And if you want to go with more details about SuperOptiX, which is easier YAML configuration, then try it out. Okay, now let's try another way. So imagine this GitHub repo doesn't exist. How can you run the Japa in SuperOptiX? So this is pretty simple. So one thing you need to do is basically, this is the repo we just tried. Japa test. Now what you should have done is basically, you should have done the Japa test directory. You just need to go into that directory. Let's open this directory inside the editor. So in this directory right now, there's nothing. So what we will do now, we will pull the agents. There are few Japa agents available in the SuperOptiX. Let's get this agent into our system. So what that means is it created the playbook, meaning you have pre-built agent with all the configuration for the Japa already there. So as you can see, you have this Japa configuration. You can just tweak that using the documentation, but this is the configuration for this agent. And next thing, we need to compile it. Once you compile, it will automatically create the DSPy pipeline for Japa that you can see it. So it is using SuperOptiX and inbuilt mixins for like different DSPy configuration. So you can see model mixin, tool mixin, evaluation mixin. So there are different mixins. Also, it has a DSPy optimizer factory, meaning all the DSPy optimizer are configured in the factory that you can use. So this is a pipeline that you can use. You can tweak it if you know DSPy. Next thing you can do is basically evaluate it. An evaluation stage is our scenarios compared against the model output. So what's going to happen in the evaluation phase is you can see all these examples that we provided into our feature. The model is not optimized. The pipeline is not optimized, so it's going to fail. Next thing we probably do is optimize the agent. The Japa is optimizing your agent. So at this stage, we're using the high configuration and llama 3.18 billion model for as a base model, and then we have reflection model LM called 0.38 billion. So this will run the optimization for a few minutes. Let's cancel it now. And imagine the optimization is done properly. Then obviously you can do the evaluation and then run the agent. So if optimization is finished successfully, you can see some scenario pass and get some score. And the final step you can do is basically you can run the agent. Now it's finished. So agent has ran and he gives some solution. One thing you can see in editor, it created the traces for all these things. Also see those traces in SuperOptiX check command that will show you all this. We have pulled one agent. Similarly, we can pull another agents. So there are data science agents. So I'm not sure if I copy everything and run it. So what's going to do? Yeah, it's going to compile, run the optimization. Obviously, the optimization is going to take some time and then time. So let's cancel it for now. This way, you can just run any agents available in the SuperOptiX and get it optimized with the Japa. So this is how you run your agent in SuperOptiX. You can optimize using Japa, or you can use like a different DSPy Optimizer to optimize it. So only thing you need to do is basically you need to configure your playbook, use a different optimizer, and you need to set some basic parameters for optimization, and you will get it everything for free. So basically, and if you know the DSPy, you can just tweak this generated pipeline. You can refactor this code by your best software engineering practices. I think that's it for now. You can find more information about this integration on SuperOptiX website page. And also feel free to try and change your LLM model already downloaded. You can use like a GPT-OSS or Quen or Llama. So you can try with the different base LLM versus different reflection LLM. So you have option to do that. And that's it for this video. Thank you so much.